Hello everyone. Welcome. It's great to have you here today. My goal is to make learning about data easy and fun for everyone. Today, we're going to explore a really interesting topic from the world of big data. We will be talking about something called Apache Hive. And more specifically, we are going to dive into a powerful feature within Hive known as bucketing. If you've ever wondered how massive datasets are managed efficiently, millions or even billions of rows, then you're in the right place. We are going to unpack this concept one simple step at a time. Now, you might be thinking, Hive? Bucketing? That sounds complicated. I promise you it's more straightforward than it sounds. Think of it like organizing a massive library. If you just threw all the books into one giant pile, finding a specific book would be nearly impossible. You would need a system. Bucketing is one of those clever systems. But for data instead of books, it helps Hive find the information you need much faster. By the end of our session, you'll understand what bucketing is, why it's so useful, how to write the code to implement it yourself. So let's get started on this journey together. We will begin with the very basics. Imagine a huge collection of data, customer information sales records. Your goal is to ask questions about this data and get answers quickly. For example, you might want to find all the sales records for a specific customer ID. If your data is not organized, your computer has to look through every single record one by one. This can take a very long time. Bucketing pre-sorts your data into smaller, more manageable chunks, buckets, making these searches incredibly fast. Our path today is clear. Definition of bucketing. Compared to partitioning, how Hive decides which data goes into which bucket. Peek at the actual file storage. Walk through the code to create a bucketed table. My promise, we'll go slow, use lots of visuals, and make sure every piece fits together. Let's begin. So, what is bucketing? Let's use a simple analogy to understand it. Imagine you have a giant jar filled with thousands of colorful marbles. You need to frequently find all the marbles of a specific color. Searching through the whole jar every time would be a slow process. Now, what if you had 4 empty buckets in front of you? You could decide to put all the red marbles in the first bucket, all the blue ones in the second green, in the third yellow, in the fourth. This is similar to partitioning, but what if you have thousands of unique colors? That would require thousands of buckets, which is not practical. This is where bucketing comes in. Instead of creating a separate container for every single unique value, bucketing lets you specify a fixed number of containers. Let's go back to our marbles. With bucketing, you would say, I want exactly 4 buckets, no more. Then, you would create a rule. The rule might be based on the letters in the color's name. For any marble, you calculate a special number based on its color, and this number tells you which of the 4 buckets it belongs to. So bucketing is the process of breaking your data down into a fixed number of manageable files or buckets based on the value of a specific column. The key idea here is the fixed number of buckets. You decide this number ahead of time. You might say, I want to split my customer data into 16 buckets. Hive then takes care of the rest. It uses a special formula, which we'll talk about later, to look at the value in the column you chose for bucketing. For instance, the customer ID column. Based on the result of that formula, Hive knows exactly which of the 16 buckets a particular customer's record should be placed in. This organization happens when you first load the data into the Hive table. The end result is that your massive single data file is now split into several smaller, equal-sized files. If you have 1 terabyte of data and you split it into 10 buckets, now, let's pull back the curtain. See how Hive decides where to put each row of data. The process relies on a mathematical concept called a hash function. A hash function is like a magic recipe. You give it an input, any input, a number, some text, a date, and it gives you back a number. The important thing, for the same input, it will always produce the same output number. For example, hash the customer ID 1138. It might always give you the number 548,291. If you hash it again, you get the same number. Hive uses a hash function on the value of the column you chose for bucketing. Let's say you are bucketing your customer's table on the customer ID column and you have decided to use 4 buckets. When a new customer record comes in, customer ID equals 481516. Hive first applies its hash function to 48,115,16. This will produce a large, seemingly random integer. Let's just pretend the hash produces the number 2,097,152. It's a big number, but it's consistent for that specific ID. But we only have buckets numbered 0, 1, 2, 3. How do we get from a big number like 2,097,152 to a bucket number between 0 and 3? This is where the modulo operator comes in. The modulo operator gives you the remainder of a division. For example, 10 divided by 3 is 3 with a remainder of 1. So 10% 3 equals 1. Hive takes the large hash value and applies the modulo operator with the number of buckets. In our example, 4 buckets. So Hive calculates 2,097,152% 4. The remainder when you divide 2,097,152 by 4 is 0. And there you have it. The record belongs in bucket number 0. This entire process, hashing the value and then applying the modulo operator, is extremely fast and deterministic. It ensures every record is placed in its correct bucket, and Hive can find it again later using the exact same calculation. Let's try to visualize this whole process to make it even clearer. Imagine we have a small set of customer data. We want to store this data in a Hive table that is bucketed by the customer ID column into 4 buckets. Our buckets are numbered 0, 1, 2, 3. Let's look at a few customer records and see where they land. Let's say our first customer has an ID of 101. Hive takes this ID, calculates its hash value, and then finds the remainder when divided by 4. Let's assume hash of 101 modulo 4 equals 1. This means the record for customer 101 will go into bucket 1. Now, a second customer record arrives with an ID of 102. Hive performs the same calculation, hash of 102 modulo 4. Perhaps this calculation results in 3, so the record for customer 102 is placed into bucket 3. A third customer with ID 103 comes in. The calculation hash of 103 modulo 4 might result in 1. Notice something interesting here? The record for customer 103 goes into the same bucket as customer 101, which is bucket 1. This is perfectly normal. The goal of bucketing is not to give every value its own bucket, but to distribute all the values evenly across the fixed number of buckets you have. Let's continue with a few more. A customer with ID 104 might end up in bucket 0 after the calculation. Hash of 104 modulo 4 equals 0. A customer with ID 105 might end up in bucket 2. Hash of 105 modulo 4 equals 2. As more and more data flows in, each record is evaluated based on its customer ID and assigned to one of the 4 buckets. The beauty of a good hash function is that even if the customer IDs are sequential, like 101, 102, 103, and so on, their hash values are spread out, and so they get distributed across all the buckets in a seemingly random but consistent way. This prevents one bucket from becoming much larger than the others. The final result is that our single stream of customer data is now physically separated into 4 different collections of data. Bucket 0 contains the records for customer 104 and many others. Bucket 1 contains records for customers 101, 103, and so on. This distribution is the key to faster performance. If we later want to join this customers table with an orders table that is also bucketed by customer ID into 4 buckets, Hive can do something very clever. It knows that all the data for a given customer will be in the same bucket number in both tables. Alright, we've covered the theory, we've seen the diagrams, and we've peeked into the file system. Now, it's time for the really practical part. How do you actually write the code to create a bucketed table in Hive? It's surprisingly straightforward. The syntax is an extension of the standard create table statement. You just need to add a few extra keywords to tell Hive how you want to bucket the data. Let's look at the syntax together. Imagine we want to create our customers table. ID first name, last name, email. We have decided that we want to bucket this table based on the ID column, and we want to split the data into 16 buckets. The key clause we need to add to our create table statement is clustered by. This is the command that tells Hive you want to enable bucketing. You follow clustered by with the name of the column you want to use for the hashing calculation, in our case, the ID column. After specifying the bucketing column, you need to tell Hive how many buckets you want to create. This is done using the into buckets clause. For our example, since we decided on 16 buckets, we would write into 16 buckets. Putting it all together, the special part of our Hive code would look something like clustered by ID into 16 buckets. This single line added to your table definition is what instructs Hive to perform all the hashing and data organization we've been discussing. It's a powerful instruction packed into a simple, readable line of code. Here's what the full but simplified statement would look like. Create table customers ID int first. Name string, last name string, email string, clustered by ID into 16 buckets stored as orc. This complete statement gives Hive everything it needs to know. the table name, its structure, the bucketing strategy, and the file format. When you run this command, Hive creates the metadata for the table ready for you to load your data and have it automatically bucketed. Let's put that Hive syntax up on the board, break it down, line by line, so every part is crystal clear. This way, you can build a strong mental model of how the different parts of the command work together to achieve our goal of creating an efficient, bucketed table. And there you have it. We've journeyed through the concept of Hive bucketing from the basic idea of organizing data to the actual code you use to make it happen. We saw that bucketing is a powerful technique for splitting your data into a fixed number of manageable chunks based on a hash value. This is especially useful for columns with many unique values, user ID, transaction ID, where partitioning would be impractical. This organization can make your queries run much faster, especially joins on large tables. We demystified the process by comparing it to partitioning. We looked under the hood at how hash functions, the modulo operator, work together to distribute data evenly across the buckets. My hope is that this made Hive bucketing feel simple and accessible. Remember, these concepts are like building blocks. Thank you so much for joining me today and subscribing to the channel. Until next time, happy learning.